All right, so now in this video, I want to talk about adding loads. And what that means essentially is that, in electrical engineering, when you're performing the studies, you are given the grid essentially. And a lot of the times, like you are not given the resistances or impedances of the loads. Or rather, you're given you're given perhaps a p-value, which is your power, saying that, hey, this is my plant is 300 megawatts, okay? And it would just say, hey, my q, and they may also say, and my power factor is about 0 point, just to keep things easy, power factor is 0.95. So what that means essentially is that they've got a bit of a reactive component. So let's say Q is equal to, I'm just gonna, assume something along the lines of 300 square. Okay, so let's assume 98.6 MVAR. Okay, and just to keep things simple, I'm just gonna assume equals 100 MVAR. Okay, and that's what you're given. You're just given P equals 300 megawatts. Power factor is this, and which in return, let's say the Q is equal to 100 MVAR, or precisely whatever that turns out to be. You can perform that calculation as well, which is not too far out from 100 MVAR. So I don't want to do this. I want to be able to take this information and put that in. And how do I do this? So if you go back to master, and then if we go back to more on passive elements, you come in here, and Pscad has provided us with this basically a fixed load option. So you can just come in here. There is a single phase and a three phase, but let's talk about three phase for one sec. So I'm just going to take it, bring it into here because I have a three phase circuit. And now I'm just going to disable this. And I'm just going to connect right in there. I don't need a ground for this particular component. All I just need to do is just connect it to the network. And let's just start filling it in. So now keep one thing in mind, that if my power is equal to 300 megawatts, that is going to be a massive load if there was something over 300 megawatts, but perhaps a data center. But let's assume 300 megawatts was a load. Then it is a three. When someone is giving you a spec sheet, that's what they're saying, is that the power being drawn needs to be 300 megawatt going into it. But when we come in here, we notice rated real power, but we need to provide this power in per phase value. So if I now write, let's say, 300 here, what PSCAD might do is that they will then have like a three-phase load like this, and then each of these would be at 300, and then it can start to draw. It will actually be drawing 900, right? So, but that's not what I want. I wanted to, I'm saying, yes, I want to be able to model a load which is 300, but since my values that I'm putting in here are per phase, so that's going to be 100 per phase. Same thing if I want the Q to be, if I want Q to be 100 MVAR, then I'm not going to put 100 MVAR, but rather I'm going to put 100 divided by 3. That's going to be 33.33. And then the rated voltage is line to ground neutral. Now, again, this is, we're going to talk about transformers, and we're going to talk about, medium voltage buses and whatnot in later videos. It's not going to be very typical for a load of that size, again, to get connected right at 230 kV with no transformers in between. But for the sake of this conversation, since I don't have any transformers in between at the moment, my grid is set up at 230, so 230 kV. So I'm going to go back in here, and I have to do 230. Now I got to do 230 divided by root 3, and that's going to give me the line to ground RMS, because this was RMS already, um, and but this was line to line. This is line to ground. It's going to give me 132.94. So I'm just going to come back here, and I'm just going to say 132.94. Initial terminal voltage, I'm just going to assume 1. PQ defined at rated voltage. Yeah, so you can define initial voltages, like if you want to add more details in that, whatever information we have put up about 100 megawatts and the 33.33 MVR, that's assuming that, it's running at that it's running at the rated voltage. But what if the voltage is up or down? You can tweak that as well if you needed to. But at this time, we're just going to keep it rated voltage. The values that we have defined up there are basically when the voltage is at the rated voltage of 230 or 132.94 line to ground. Number of parts in the composite load. So this is about, where you could probably define this component is more about if you want to be able to define your load mix. So like, you may have motors, you may have some capacitors, you may have a big load mix, and if you want to be able to define that information, so number of parts in a composite load, number of cycles before load release, these are all related options. I'm not going to get into the details of it, but I can give you a hint. You can click on help, go in there. We'll kind of talk about the background calculations performed, and how you can give more details about what your load may look like in real life. But for the sake of this video, Pscad basic series, I'm just going to assume that, it's just one type of load, and scaling factor is about, if you write 2.0, it would basically just multiply the P power and then the reactive power by that scaling factor. So I'm just going to keep it at 1, and I'm going to say display details yes. And internal outputs, these are just the signals, so like you can name it like resistance underscore signal, and then you can scope it, you can use it if you needed to. But you don't need to define any of this if you just want to make the compiler work and if it's not important to you. So I'm just going to say press OK. So in this case, yeah, so I'm going to keep this at 0 as well for now and press OK. All right, so let's run the simulation and see how much power are we expecting, because we put 100 per phase, so we should be pulling this particular multimeter should be showing that we are pulling 300 megawatts with about 100 MVAR from the circuit, and we should be able to see that on our graphs on the right side here. So when it compiles, so it's finished compiling already. So it's just, and yeah, so at the bottom right here, just one more note here at the bottom, if when you see these gears and the gears are moving, that means it's doing something. So sometimes you notice that it's not doing anything, but if these gears are moving, that means the Pscad is still running. And this right here, 760-585, that's kind of like your cursor location where it is, and it gets very interesting. Like you could use that this canvas location information when you're actually doing Pscad automation. You can tell the components to go and be located in certain locations on the canvas when you are performing those Pscad automation tasks. Coming back to our original task at hand, in this particular case, you could see right here, right there, we are now at 300, roughly about 300 volts. There's a plus minus and there's a spike as well. Again, we're not going to get into details of that at the moment. And you also, just for you guys to know, that you could see like how these oscillations are higher, and then they kind of get lower. But the idea is that's how you can you are pulling about 200, around like 300 megawatts, because this is a per phase values that you've put in, and that's how you can kind of put in the load and no longer be relying on the resistors or inductances and whatnot. That's how you would actually be you would see that in the models where you would have loads kind of specified that way. So I hope that helps, and we'll see you in the next video.